Hello, everybody. Very nice to meet you, even though through the video tape. The presentation we are going to give today, titled Influence of Nanotechnology Related to Socio-Scientific Issue Program on Competencies of a High School Student in Korea. The presenters are myself, Hae-Ae and Hye-Sook Lee, Soonok Kim from Busan National University, Korea. A changing, interdependent, and conflictual society today demands education reform. School subject-bound curriculum barely prepares individuals to function well in such cases facing the present and future challenges. Individuals are not well educated to lead a successful and responsible life in contemporary society. OECD program initiated to equip students with a new skill and competency. Such a competency includes using tools interactively, interacting in heterogeneous groups, and acting autonomously. Further, the PISA 2015, especially scientific inquiry, includes explain phenomena scientifically, evaluate and design scientific inquiry, and interpret data evidence scientifically. On the other hand, science education increasingly focused on socio-scientific issues, and society will benefit if science education encouraged students to adopt more positive and realistic view of science. In the similar context, science curriculum in Korea adopted competence-based curriculum in 2015, including scientific thinking ability, communication ability, and others. However, a few programs adopting competency-based curriculum in Korea, their effectiveness has not yet investigated. On the other hand, technology in our contemporary society is rapidly developing and continuously changing, and new technology keep producing new items in the market. In this context, individuals are required to have appropriate ability, attitude, and competence in science to reach solutions. In this study, we aimed to examine how a nanotechnology-related SSI program influence on competencies of high school students in Korea.
Research questions. Does the program influence on students' competence of use tools interactively? Second, program influence on student competence required for scientific inquiry. Third, influence on student competence interact in heterogeneous groups. Research subjects include 30 students, 10th grade, 9 females and 21 males, from two high schools, Busan, Korea. Survey instruments consist of 50 items, 5 Likert scales, 5 items for each competency. Semi-structured questions about program effectiveness. Each student was interviewed for 20 minutes after program. Survey instrument items. Procedures. Analyze competency and then extract competency element, and program development and implement, and collect data and analyze. Program overview consists of Part 3. Part 1, what are the silver nano washing machines? And Part 2, let's test their antimicrobial effects. Part 3, buy or not buy. Part 1 focuses competence using tools interactively. Identify appropriate information sources from Internet database. Students recognize and determine what is unknown with a need-to-know board. After gathering information from website and other sources, students prepare to present to the whole class. Teacher present images of silver nanoparticle, and the student investigate the silver nanoparticle with a need-to-know board and choose one of different interest groups as stakeholders. This picture shows Part 1 learning activity. Part 2 focuses competency required for scientific inquiry. Student questions in antimicrobial agent inquire how to these claims. Students have an opportunity to have in-depth discussion about valid experimental designs. Part 2, recognize the problem, formulate the hypothesis, design and perform experiment, and analyze data and draw conclusions. This picture shows the Part 2 scientific inquiry. Part 3 emphasizes the competency interacting the heterogeneous groups. 4 instructional strategies of this part: a role-playing debate and the jigsaw model. Students in a group were given one of 5 roles. Each group of students present a recommendation based on information and argument. Jigsaw model is present problem, situation, and role. Discussion 1, group activity in the same role. Discussion 2, group activity within 5 different roles. And group presentation of positions adopted during discussion 2. This picture shows Part 3 jigsaw model.
For the result, does the program influence on students' competencies of use tools interactively? We found that significant increase in students' competencies of using tools interactively. From interview, student told, is a silver nano washing machine expensive? I checked the internet. There are cheap and some expensive washing machines. When I looked at other data. Research question 2. There was significant increase in students' competencies required for scientific inquiry. Student told, I remember doing experiment with silver nanoparticle. Another student, I conclude from experiment that silver itself is not a carcinogen. Further research question 3. There was no significant change in students' competency of interact in heterogeneous group after program. Student thought it was good to take the role of each and understand the position of other interesting groups. Another student, I enjoyed explaining various aspects from social, environmental, and scientific viewpoint. Finally, conclusions. Nanotechnology-related SSI program influenced on students' competencies of use tools interactively, and PISA required from scientific inquiry, but do not influence on competencies of interact in heterogeneous group. Our suggestion in instructional strategy for part 3, interesting in heterogeneous groups, may be needed to reorganize for student deeper reflections on different interesting groups. Thank you for your attention. If you have a question, let us know. Thank you.